Hello everyone, today we are going to present an optimization problem using calculus. Optimization is the process of finding the maximum and minimum value of a quantity while following certain conditions or restrictions. Our problem is the following. A farmer has 200 meters of fencing and wants to build a rectangular corral next to a river. Since the river forms one side of the rectangle, only 3 sides need to be fenced. We want to find the dimensions that will produce the maximum possible area. First, we draw the rectangle and label the 2 shorter sides as X and the longer side as Y.
To solve this problem, we need to identify the restriction. The farmer has only 200 meters of fencing available. Since 2 sides have length X and 1 side has length Y, the total amount of fencing used is 2x plus y is equal to 200. This equation represents our constraint. Next, we solve for y because we want to write everything in terms of a single variable. That's equal to y equals 200 minus 2x. We will use this expression later when creating the area function.
Area function. Now we need to create the function that we want to optimize. The area of a rectangle is calculated by multiplying the length by the width. A equals x, y. Since we already know that y is equal to 2000 minus 2x, we substitute it into the area formula. Ax is equal to x times 200 minus 2x. After simplifying, we obtain a of x equals 2000x minus 2x. This is a function that represents the area of the corral, and our goal is to find its maximum.
To find the maximum area, we use derivatives. We take the derivative of the area function, 200 minus 4x. Next set, we set the derivative equal to 0 because of maximum and minimum values occur at critical points. So 200 minus 4x equals 0, and solving for x equals 4x equals 200, and x equals 50. This tells us that the 2 short sides of the rectangle should each measure 15 meters.
Now we substitute the value of x into our constraint equation, like y equals 200 minus 2 times 50 and y equals 100. To verify these points gives a maximum area, we calculate the second derivative. And since the second derivative is negative, the function is concave down, which confirms that we found a maximum. Finally, the maximum area is 50 times 100 equals 5,000 square meters. In conclusion, using calculus and derivative, we determined that the farmer should build a corral that is 50 meters wide and 100 meters long to obtain the largest possible area.
It is important to mention that this project shows how calculus can be applied to real-life situations. By using derivatives and optimization, we can find the most efficient solution to a problem. Throughout this course, we learned that calculus is not only about mathematics, but also about understanding and practical problems.